In this video, I'll show you how to solve the ALEKS problem called calculating key distances in the FCC unit cell. Be careful, there is a very similar ALEKS problem where it's asking you to calculate key distances in the BCC unit cell. This particular video is just for the FCC unit cell problem. So this has got a sketch of a unit cell. You'll notice that it's got three corners of the unit cell colored red, green, and blue. And it's going to give us some information about distance between two of these corners, and then it's going to ask us to calculate the distance between two other corners. I'm going to start by redrawing this cube, but I want to draw it head on. So we're going to draw it just so it looks, actually it's going to look like a square, and here is my green corner, and here is my blue corner, and here is my red corner. And the other corner that is in gray, we're just going to leave that out. So ALEKS is going to give you the distance between two of these three corners. For me, I've been given the distance between the red and the blue. That's this distance right here. I'm just going to go ahead and sketch that in, and that is 0.272 nanometers. And then it's going to ask you to calculate the distance between two other cubes. So for me, it's asking me to calculate the distance between the red and the green. So if this kind of looks like a triangle to you, that is because that is just a regular triangle. And we're going to solve this problem just using regular Pythagorean theorem, a squared plus b squared equals c squared. If it's been a minute since you used this equation, I just want to remind you that the a and the b are the shorter sides of the triangle, and the c needs to be the longer side of the triangle. And the relationship between these three sides is a squared plus b squared equals c squared. So one of the things that I do want to point out to you with this particular cube is that this side length A is exactly the same as this side length B. These two are exactly the same. So we can do a little bit of algebra with this, or not necessarily algebra, but we can just say that B is exactly the same as A. Those two side lengths are exactly the same. So we can kind of change this equation right there to say a squared plus a squared equals c squared, or 2a squared equals c squared, which we can do just by adding these two terms together. And that's going to give us whatever relationship we need to solve this problem. So ALEKS is either going to give you one of these lengths. It might give you the red to green. It might give you the green to blue. But you're going to recognize that if you've been given this length, you also know this length as well, because they are exactly the same. So it's either going to give you this length or this length and ask you to solve for C, or vice versa, which is what my problem is. It's giving me C and it's asking me to solve for this length over here. Then this just becomes a regular algebra problem. I know C, so I'm going to plug in 0.272. I'm going to leave the unit off just for space, just to kind of save space. 0.272 squared. I'm going to divide both sides of this equation by 2. So I'm going to get a squared is 0.272 squared divided by 2. And then I'm just going to take the square root of the whole entire thing. And actually, I'm just going to put it in my calculator. So 0.272 squared, and then that number divided by 2, and then I'm going to take the square root of that whole entire thing, and for A, I get 0.192, and that unit was nanometers. It wants it to three significant figures, which is exactly what I've got, and 0.192 nanometers. That's all you got to do.